Number 12.2. In the study of cigarette demand in this chapter, suppose we use as an instrument the number of trees per capita in the state. Is this instrument relevant? Is it exogenous? Is it a valid instrument? Answer 12.2. The number of trees per capita in the state is exogenous because it is plausibly uncorrelated with the error in the demand function. However, it probably is also uncorrelated with the natural log of big P superscript cigarettes, so it is not relevant. A valid instrument must be exogenous and relevant, so the number of trees per capita in the state is not a valid instrument. Number 12.3. In his study of the effect of incarceration on crime rates, suppose Levitt had used the number of lawyers per capita as an instrument. Would this instrument be relevant? Would it be exogenous? Would it be a valid instrument? Answer 12.3. The number of lawyers is arguably correlated with the incarceration rate. So it is relevant, although this should be checked using the methods in section 12.3. However, states with high crime rates with positive regression errors are likely to have more lawyers. Criminals must be defended and prosecuted, so the number of lawyers will be positively correlated with the regression error. This means that the number of lawyers is not exogenous. A valid instrument must be exogenous and relevant, so the number of lawyers is not a valid instrument. Review the concept 12.4. In their study of the effectiveness of cardiac catheterization, McClellan, McNeil, and Newhouse, 1994, used as an instrument the difference in distances to cardiac catheterization in regular hospitals. How could you determine whether this instrument is relevant? How could you determine whether this instrument is exogenous? 12.4. If the difference in distance is a valid instrument, then it must be correlated with big X, which in this case is a binary variable indicating whether the patient received cardiac catheterization. Instrument relevance can be checked using the procedure outlined in section 12.3. That is, form regressing big X, the binary treatment variable on big Z, the distance variable, and any included exogenous variables, big W. Checking instrument exogeneity is more difficult. If there are more instruments than endogenous regressors, then joint exogeneity of the instruments can be tested using the big J test outlined in key concept 12.6. However, if the number of instruments is equal to the number of endogenous regressors, then it is impossible to test for exogeneity statistically. In the McClellan, McNeil, and Newhouse study of 1994, there is one endogenous regressor treatment and one instrument difference in distance, so the J test cannot be used. Expert judgment is required to assess exogeneity.